Today you're going to learn about parabolic conic sections. That's the title of today's lesson. And in this lesson we're going to talk about parabolas. Now, to this point we've learned about parabolas that open up and down. Not only are they quadratic functions or quadratic equations, they're also quadratic functions because they would pass the vertical line test. Today we're going to learn about parabolas that not only open up and down, but also open to the side. And every parabola we talk about today has a few new parts to it that you never knew about. The first is called the focus, and it is a point inside of every parabola. I call it like the food, and explain why in a little bit. And on the opposite side of the vertex, you will have a line called the directrix. Now, there is a correlation here. With every parabola, let me do it in a color here so it stands out. With every parabola, think of it as a Pac-Man. It's a mouth eating something, and the mouth always wants to eat the food, the focus. Now here is the correlation between the focus and the directrix. You can go to any point on the parabola. Let's start with the vertex. The distance from the focus to the vertex will always be the same distance from the vertex to the directrix. You can do any point on the parabola, like here's another point. The distance from the focus to any point on the parabola will be the same distance from that point on the parabola back to the directrix when you're making a 90-degree angle with the directrix, okay? Any point on the parabola, back to the directrix, exact same distance. In your note, the first thing I'd like you to do after you write down what the title of this lesson is. So this lesson is going to be Parabolic Conic Sections. And today we're going to learn how to graph a parabolic conic section. And we're going to learn how to identify 6 main features of it. And we're also going to do like the opposite. We're going to be given a graph of a parabolic conic section, and we're going to come up with the equation of it. So here's some things that we're going to refer back to. We're just going to make some notes here.
Do we write that down?
Yes, please. These are the parabolas that you're used to working with. They open up and they will open down. Not only are these quadratic equations, we also refer to these specifically as quadratic functions because they pass the vertical line test, making them a function. And the general equation we're going to refer back to here with this is x squared equals 4py. We'll discuss how we use that and what the p means in a little bit. The two others, instead of opening up and down, they open to the right or to the left. These are new ones. Yes, these are quadratic equations, but they're not quadratic functions because they would not pass the vertical line test. The general equation we'll use here is y squared equals 4px. These are equations you'll have to memorize, and you'll understand that midway through this lesson you'll have done it enough that it comes pretty easily. We will be referring back to this throughout the lesson today. Your first learning objective will be able to graph a parabolic equation and identify 6 characteristics about that equation. Okay, so what I would like you to do is I would like you to write down this equation. Now, before I can start to graph this or fill out any of the 6 pieces, I need to isolate whatever variable is squared. In this case, it's the y squared. So I'm going to come off to the side here and write x equals negative 1/6 y squared. In order to isolate the y squared, I want to move the negative 1/6 to the opposite side. In order to do that, I'm going to multiply by the reciprocal. The 1 and the 1 simplify to 1, and 6 divided by 6 simplifies to 1, and a negative times a negative is a positive. So by multiplying by the reciprocal, I'm left with just y squared, and that was my goal. On the left, negative 6 times x is negative 6x. Now we're in a position to make a prediction. I have a problem that is y squared equals something. So I'm going to go back and look at the graphs I have. Because it's y squared, I know that my parabola will either open up to the right or it'll open up to the left. That's what I know right now. It's either going to open to the left or to the right. Once we identify the p, not only can we graph this, we'll be able to know which direction it actually opens up. I'm going to rewrite this equation, and I'm just going to put the y squared on the left-hand side. So y squared equals negative 6x. And directly underneath it, I'm going to write that general equation, y squared equals 4px. Now, because I have y squared equals a quantity and then y squared equals another quantity, I can use substitution to substitute this in for the other y. So really, in essence, these y squares go away and I set these two equal to one another. In doing so, I can now solve for p. So to solve for p and isolate that variable, I'm going to divide both sides by 4x. On the right-hand side, thank you, on the right-hand side, the x's, x divided by x is 1, 4 divided by 4 is 1. A lot of time we're programmed to say cancel. That's what, in my mind, I even think that. But remember, in reality, they just divide equaling a 1 and then kind of become invisible when it's a 1. So now I have p equals x divided by x is 1, and this simplifies to negative 3/2. If you're like me, sometimes I like to work with decimals instead of fractions. You can write p equals negative 1.5, or that's equivalent to negative 3/2. Whichever one you prefer. I'm going to do the decimal, but you're welcome to use the fraction. This tells us a lot. This allows us to finish this very quickly. If your p is negative, we're going to come back here. I'm going to write negative p and negative p. Vice versa, this is a positive p and a positive p. I already knew that the parabolic equation would produce a parabola that either opened to the left or right because this was y squared. Once I solved and found out that p was negative, I was like, oh, okay, my parabola is going to open to the left. So I'm actually going to come over here and I'm just going to draw a little picture. Opens to the left. Now I get to do a rough graph of what this would look like, and then I'll go back and answer these 6 characteristics. This particular parabola, you're going to see later on when it doesn't, has the vertex at 0, 0. I'll show you an example when it does not have a vertex of 0, 0 and what that looks like in the next problem. And I know it's going to open up to the left. So it's going to open up like this. Remember, think of this like a Pac-Man mouth, and it has to eat the food, which is the focus. So I'm going to go 1.5 to the left of the vertex, 1.5 to the left of the vertex. I'm going to make a dot. That is my focus. And I'm actually going to draw, this is my parabola. It's eating the focus. And then on the opposite side of the vertex, the same distance, so instead of going 1.5 to the right, or to the left, I'm going to go 1.5 to the right. I draw the directrix. Answering these 6, so opens up to the left. The vertex is at the origin, 0, 0. The focus can be found at negative 1.5 and 0. The p-value is p equals negative 1.5. The directrix cuts through the x-axis at 1.5. It cuts through the x-axis at 1.5. And the axis of symmetry, if we were going to take and we were going to split this parabola in half, making it symmetrical, it would cut through the y-axis at 0.